Our third speaker on this technical seminar is Dr. Veeranna Channashetta. He is Associate Director, Environmental and Industrial Division in TERI. Dr. Veeranna Channashetta is Associate Director, Environmental and Energy Division of the Energy and Resources Institute, TERI, New Delhi. He has 20 years of experience in biotechnology, agriculture, social science, and management of natural resources. He works as a techno-commercial industry interface, and among his expertise areas are the remediation, reclamation, and rehabilitation of sites polluted by hazardous waste. Additionally, he has expertise in bioremediation of industrial waste, pesticide, and petroleum hydrocarbon contaminated sites. He has worked on environmental assessment, management, and evaluation projects with the oil sectors at both the national and international levels. Dr. Veeranna, now it's open for you.
I am the last batsman of this event, and thank you very much for introduction, sir. I am one of the odd man here because I am representing a research institute. Actually, basically I'm a microbiologist. We do the research related to the environment and any industrial problems. And TERI is an organization which is mainly involved in the research related to the environment and advocacy of climate change and policy making. This year is very important for us because our organization has completed 50 years, and I have been this part of this organization for more than 20 years. And we have developed a green technology called this oil zapper technology. This is a bio-based bioremediation technology. This has been used by oil industry for the remediation of oil spill contaminated sites and the oil waste generated during the oil industry processes. I consider this as a technology as a driver and enabler of the change because it has a low carbon footprint and it has a mitigation of the GHG emission, and it also minimizes the environmental impact of the oil industries, and also it is a sustainable technology. Coming to the introduction, pollution is nothing but release of any harmful substance into the environment, and anything is released into environment has a negative impact on the human life, animal life, and plant life also, and it in total it imbalances the ecosystem and it creates the problem in environment. So controlling pollution is not just has to be an environmental necessity or just environmental compliance, but it has to be a fundamental aspect for ensuring public health and economic stability and social equity. So what we can do, we can mitigate the adverse effect of pollution by adopting effective pollution control measures, investing in clean technologies, and creating awareness of environmental awareness. Then by that we can promote a healthier and more equitable world. See, as I mentioned, oil industry generates the oil waste during different processes. Oil industry has a different processes like upstream, midstream, and downstream. During the upstream, during the exploration and oil drilling, there will be a solid oil waste will be generated. That can be treated with this oil zapper technology. Similarly, during the midstream, there is also a solid waste created that is also can be treated with oil zapper technology. And even in downstream, like a manufacturing, refining process, unavoidably there will be a generation of solid waste which has a hazardous in nature that can be also treated using this oil zapper technology. Different types of industrial pollutants and impacts of industrial sectors. We already, from the morning, we are discussing about the different pollutions. Here, our technology can apply for the soil pollution and hazardous waste pollution. And you know the environment impact of these all pollutions. It has a GHG emission, and it can be a land and water pollutant also. And contribution of the oil sector towards GHG emissions is huge. It is one of the major emitter of the greenhouse gases. You can say oil refineries around 5 billion tons of CO2 annually they will release into the atmosphere. And the disposal of this oily waste generated during the drilling or oil refining and other activities presents various environmental challenges, and it has even a carbon pollution concern, and it has a carbon footprint also. And this contributes to the global warming and climate change, thus highlighting the need for more suitable practice in industries required. If you see the sources of environmental impact in the oil industry, suppose oil sludge storage pit, you can see if it is stored, it has a land usage problem there. Even if it is contaminated to the land, that land will become unfertile and it cannot be used for other purpose also. Even when there is a pollution in the water, it definitely affects the marine system of the water. And similarly, if you see even there is a storage inside the operational area, that also makes the limitation of land use, and it also creates a problem for the environment present in the area. And even there is if any oil contamination occurs in the farmer's land, because most of the crude oil pipeline, the supply line are passing through the farmer's land and agriculture's land. If that is there any spillage that causes the reduction of the soil fertility, and even it causes the economic loss to the farmers. By using our technology, we can restore and reclaim this land. Waste from the oil industry can contribute to carbon emission, as I mentioned. If you choose the direct carbon emission during the disposal, if you choose the disposal through the incineration, this incineration has what it will do. It will during this process, definitely, because we are using the high energy to burn the solid waste, it will cause the CO2 emission. Apart from that, it has a GHG emission. And this process also converts the carbon present in the solid waste into the CO2, and that is released to the atmosphere. And apart from that also, during the incineration process, there is other products also like dioxin and furans and particulate matters created. And especially these dioxins are having the POPs, that's called persistent organic pollutants, that have an effect on the human health, like it can be cause a cancer, or even it has a liver damage, and it affects the human liver system and hormone system also. Even if you choose other methods to dispose for this, like a thermal desorption or a chemical treatment, that also leads to the CO2 emission into the atmosphere, and it also similarly GHG emission also it will be there. If you look into the carbon emission from the different methods using, if you see even oil recovery, when you are using the oil recovery method for from the oil suds or oil soaked soil, that is a supercritical extraction you have to do. And even though it is an efficient method, but it requires energy to generate and maintain the supercritical condition, which contribute to the carbon emissions. Similarly, when you want to dispose this oil sludge or contaminated soil, you have to take the transportation to the disposal facility. During the transportation and during the process of disposal also, there is a contribution of CO2 to the atmosphere. When you look at this bioremediation technology and its carbon impact, it has a very minimal carbon footprint compared to the other technologies, because carbon emission associated with the energy needed for this process is very less, and even chemical requirement for this process are very less. And because this basically uses the naturally occurring microorganisms present in the nature. If you compare the different carbon emission from the different technologies, you can see the most carbon emission through the incineration, followed by this chemical treatment, and this other. If you look at the bioremediation, it has a minimal CO2 emission. It is overall GHG emission. If you see sector-wise, there is industry contributing 28%, as earlier we are also discussed in the other session also. Power sector is contributing to the emission for more than 34%. Environmental concern of the refineries. If you see how they are disposing, if you see, it is a general study it has shown that more the people are using the land filling for this hazardous waste disposal, and followed by the incineration. Only around 10 to 12% these refiners are using through the bioremediation. So there is a scope for adopting this technology. And there is oil refineries also contributing CHG. Already earlier presentation also you have seen these things. Industrial pollution control, how we can do this emission control system using installing the filters and scrubbers and other technologies. You have to energy efficient technology you have to adopt. Sustainable material you have to use for producing the environment friendly materials. In the waste management, you can use the clear technology like algebra technology, and if the industry has to get a green certification, which can be either monetized or it can be get through the like a carbon offset or a carbon credit they can get, then only this will promote the environmental compliance by the industries. How to prevent environmental impact of the industries? It can be done through the promoting environmental awareness, better waste management, improved recycling, as you know that 3R reuse, reduce and all the things you can practice, and smart land use, greenhouse gas mitigation. Advanced technologies like algebra can play important critical role in mitigating environmental pollution by reducing emission, cleaning up the pollutants and preventing the contamination. There are different kind of pollution we are already discussing. Since the time is less, I'll just concentrate on pollution related to the soil pollution and hazardous waste pollution. This soil pollution can be addressed through the bioremediation. That bioremediation can be done through the algebra technology, which is a greener technology. And bioremediation is the process that already I told, it employs the organism that is bio-based, and it's capable of degrading the toxic contaminant present in the hazardous waste. And these organisms are naturally occurring, and this is the best safe disposal of sludge without affecting the quality of soil and groundwater. Adopted by these refineries and oil producing companies as the way to dispose this toxic is the best way for disposal of this hazardous waste. I just don't want to go through this circle of bioremediation because of time constraint. As I said, this is the algebra technology developed by the TERI, and it is used in bioremediation, and it is being adopted by most of the oil industry in India and in Middle East countries also. Insights of this composition of this technology, what I say, everybody knows that crude oil has different fractions like alkane, aromatic and asphalt and NSO. In this technology, we have a consortium of different bacteria which can act on the individual component of the crude oil, and this technology advantage also that it can work in different environmental conditions like low temperature 15 degrees centigrade and up to higher temperature 60 degree temperature. And even at saline condition also this technology can be work. And this technology is non-pathogenic because we are using the naturally occurring microorganism, and it's eco-friendly, easy to handle, and degrades contamination within 4 to 5, 6 months. And this is easy to handle because it is in a powder form. It can be applied like agriculture, fertilizer or amendments on the contaminated land. And this technology has all the compliance, because compliance ensures the safety and efficacy and environmental protection of the product. And this is the one you can see for the example, and this is a bioremediation site from the ONGC. It is before bioremediation, after bioremediation. You can see these the plants are affected with the oil spillage, and after bioremediation it has been restored and reclaimed. Similarly, other site where it is land is reclaimed and restored. And we also tried this in the Middle East country like Kuwait Oil Company. There also we have applied this technology to recover the land and restore for this. If you see comparative analysis of this technology with conventional techniques, what I can say, if you compare incineration, land filling or chemical treatment, this algebra technology is a green technology because it is a lower cost with high recovery rates and less environmental impact. Yes. Industrial greening leading to the reduction, you can do with all these practices. Algebra technology is the driver of sustainable solution for oil waste management, because using this technology, more than 1 million metric ton of oil sludge or oily soaked soil is treated in India and Middle East countries, and vast area of oil contaminated agriculture farmers land reclaimed and restored. And this technology has helped in carbon footprint mitigation. By adopting this algebra technology, Indian industries paved the way for sustainable development. Key takeaways from this are from this session, what I can say is technology as a catalyst. For advanced technologies are crucial in driving significant improvements in the environmental pollution control, and diverse application you can go for, and effective solutions such as this algebra technology can be used. There is a last thing is that regulatory and policy support is required. Technology impact is amplified by supportive regulations and policy that drive into adaptation or effectiveness. Thank you.
Thank you very much, Dr. Veeranna, for the presentation. Oil zipper technology, yes, I have got myself a first-hand experience through OTBL, so I can vouch for that. Yes, it works very well. But this comes into picture only when some leakage has already taken place, and normally our endeavors are to see to it that there are no leakages because this is our bread and butter. So why the oil should get leaked to the soil? Before we open it for the question and answer session, let me say that the technologies that we have been presented here with definitely are going to help us in arresting the adverse impact on environment which are caused by pollutants. The demand for this and other types of technologies will be increasing in times to come because of the stringent regulatory requirements as well as the self-complying measures adopted by various entities, and also because on account of the increased awareness or consciousness that will be engulfing the industry as a whole. There will be more research and innovations, and let us hope that more and more technologies will be coming forward which will take care of all these kind of adverse impact that we are going to create to the environment.